Math TV, where you solve, learn and thrive. My own name is Toib. I will be your tutor for MTS 203 with the title Linear Algebra 1. So in this course, these are the course content for this course. So we start with linear system or system of linear equation in accordance with matrix algebra. Then we have the inverse and transpose of the matrix, and so on and so forth. So in this video, we'll be taking ourselves linear system. What's a linear system? Linear system, you can also call it system of linear equation. It's just the combination or the combination of two or more okay, system of linear equation. The definition for that is just the what? Combination of equations with one or more variables in it, and then the equations must be two and above equations with more variables. So system of linear equation can be in three forms. We have the underdetermined system of linear equation, we have the underdetermined, we also have the well-determined system of linear equation, and we also have the overdetermined. So each of these systems, they have their own characteristics. For the underdetermined system of linear equation, this is the case whereby we have more variables more than the unknown, or we say more variables more than the equation rather. Example for that, example for underdetermined, that's where we have x1 plus 3x2 minus x3 equals to 5, and then we have 2x1 minus 2x2 minus 5x3 equals to 0. These are examples of an underdetermined system of linear equation. As you can see, we have three unknowns here, which are x1, x2 and x3, and we have just two equations. So another characteristic for this is that they have more than one solutions, or they have no solution. Is that they have more than one equation, more than one solution? Okay, the second type of system we have is the well-determined system of linear equation. In that case, we just have the same numbers of unknowns with the equations. That is, we have same variables with the unknowns. Examples is just like our normal simultaneous equation. Let's say I have, or let me use this one. Let's say I have 3x3, 3x1 minus 2x2 minus x3 equals to 1. So in this case, you can see that we have what? The well-determined system. Well-determined system. How is it well-determined? We can see that we only have the what? 3 unknowns and 3 equations. So the major characteristics of this is that it has unique solution. That is, the solution is unique. Any value you get for your unknowns, they are always unique. So, and the last one is the what? Overdetermined. Overdetermined is just the case whereby we have more equations than the unknown. Let's say my unknowns is just x1 and x2, and my equations is now 3. Let's say this is the case. So in this case, this is an overdetermined system of linear equation. So the characteristics of this is that what? It has, is either it has no solution or it has a unique solution. Is either it has no solution or unique solution. You can see that their examples are different. Here I have just two variables, x1 and x2, and I have 3 equations. Okay, we have different methods of solving system of linear equation. So the normal way of solving our simultaneous equation can also be used here, which is the elimination method. Another method of solving this is the row reduce method, which can be in two ways. That can be, we have the reduced echelon form, and you also have the row reduced echelon form. row reduced echelon form. Okay, this one is the reduced echelon form, and this one is the row reduced echelon form. This row reduced can also be called the canonical form. The canonical form of solving. So we'll get there. Let's treat one example. Okay, so this is an example of a system of linear equation. How do I know that it is a system of linear equation? I can see that I have my unknowns and I have my equations. System of linear equation can be represented like this, in this form. In this form, ax equals to b. Ax equals to b. Where my a is my what? Is my coefficient of my unknowns, of my variables. My x stands for the variables I have, and my b stands for my what? My results of the system. So I want to use the simple elimination method to solve this. And how do I go about that? I can see that my equation 2 is a bit less complex for me to use. So let me make z the subject. I can just say z equals to 2 minus x minus y. And then for me to have z as the subject here, I can easily substitute my z in my equation 1 and 3. So let me simply do that. 3x plus y minus 2 in bracket 2 minus s minus y equals to minus 2, and also 2x plus 4y plus 2 minus s minus y equals to 0. Yeah, okay, let me open the bracket. So I have 3x plus y minus 4 minus plus 2x plus 2y equals to minus 2, and also I have 2x plus 4y, no, I have x then plus 3y equals to minus 2. Okay, let me simplify the first one. I have 5s plus 3y equals to 2, and the second one I have x plus 3y equals to minus 2. So now I can see that my equation is now a little bit simpler, which I can easily use my elimination method to solve this. So I can just subtract equation 2 from 1. Let me call this my equation 3, and this is my equation 4. So subtract equation 4 from 3, and that will give me 4x equals to 4. I can see there that my x equals to 1, just like that. So for my x equals to 1, I can get my y. I can get my y from my equation, from this equation, and my y will just be 1 plus 3y equals to minus 2, and then I have 3y equals to minus 3, so y equals to minus 1. So my x is 1, y is minus 1. So I can know my, so I already know my x to be 1, y to be minus 1. So on getting z, I can easily call back this my equation to get my z. So z will just be 2 minus 1 minus 1, and that gives me 2 minus 1 plus 1. So my z is 2 from there. So now I know my solutions to this system of linear equation. That is, I know my values for my x, y, and z, which are x, y, z are 1, minus 1, and 2. So for you to check, you can just substitute your values in any of the equations. They must give you the values, their answers. So that's how to solve using the normal elimination method. The second method we can also try is the reduced echelon form, or the row reduced echelon form. Know our values of the unknown to this example, to this system. So let's try our method 2. Our method 2, which is the reduced echelon form for this. So don't forget what I wrote initially, which is ax equals to b. So this system of equation, I can easily represent this in this form. Try to set it as an argument in a matrix: 3 1 minus 2 1 1 1 2 4 1. Then my unknowns are x, y, and z. So my results are -2 2 0. So this is what I mean by this. So for me to use the reduced echelon form for this, I know my leading diagonals for this matrix. The reason I call it leading diagonal is because I have a square matrix. I have a 3 by 3 matrix. In the case of overdetermined or underdetermined, these are called pivoters. They are called pivoters, in which my pivot elements are the first unit element in each rows. Yeah, my pivot element, they are the first unit element in each rows. So for this my equation 1, for me to have this as my pivot, I must make this my 3 to be 1, and then after that I must make sure that every element under it are zeros. And for my second pivot, which is 1 already, I must make sure that element under it is 0 as well. So how do I go about that? I need to reduce my 1 here to make it 0. And for me to do that, for me to achieve that, I can just say 3 row 2 minus row 1. If I do that, I'm sure that my 1 here will be 0. And okay, yeah, let me try that. So my first row is 3. To solve this, what I have here, using the reduced echelon form, I need to set my results here into this matrix, and that will give me 3 1 minus 2 minus 2 1 1 1 2, and also 2 4 1 0. Why did I need to do that? Because every everything I'm performing on each row must act on these values too, for me to have my result correct. So yeah, let's go. So I need to reduce this second row. Why did I need to do that? Because I need every element under my pivot. My pivots here are 3 1 and 1. Every element under my pivot must be 0. So I need to make this 1 0. So how can I attain that? I can just say 3 multiplied by row 2 minus row 1. You can see that 3 multiplied by row 2 minus row 1. So on doing that, I will have 3 times 1, 3, minus 3, 0. So that will give me 3, 1, minus 2, minus 2. So that will give me 0, 0. 3 times 1, 3. 3 minus 1, 2. 3 times 1, 3. 3 minus 2, 5. 3 times 2, 6. 6 minus 2, 8. That's great. So for me to make this 0 2, I can just say 3 row 3 minus 2 row 1. Yeah, that's the best way to eliminate these two. What I just did is that I multiply each row by the what? The interchange of their first value for me to have 0 here. So I can just say 3 times 2, 6. 6 minus 6, 0. 3 times 4, 12. 12 minus 2 times 1, 2, which is 10. 3 times 1, 3. 3 minus 2 times 2, 4. Do you get that? 3 times 1, 3. 3 minus minus, and then 2 times 2, 4. 3 minus 3 plus 4, 7. And also 3 times 0, 0. 0 plus 4, 4. So we are on the way. So the next thing is to eliminate my 10 here to make it 0. I already achieved this to be 0 and 0. The next thing is to make my 10 0. And how do I get that? For me to make that 0, I can just use my row 2. In this case, I won't use my row 1, because if I should use my row 1, I will still have a value here which is not 0. So I will make use of my row 2. And how do I do that? I can just say row, I want to eliminate 10. So I can just say row 3 minus 5 row 2. Yeah. And that will yield 3, 1, minus 2, minus 2, 0, 2, 5, 8, and then 0 minus 5 times 0, 0. 10 minus 5 times 2, 10. That's 0. And then 7 minus 25, minus 18. Minus 18. 4 minus 5 times 8, 40. 4 minus 40, minus 36. Okay, we can see now that, don't forget to put this line. Don't forget that. So we can see now that I have every element under my pivot to be 0. So you can just say, since I'm here, I can just say that minus 18z equals to minus 36. Look at how I pick it, because I have my last pivot on my third row. So I categorize my third column to be z, y, and x. So that's why I have minus 18z to be equals to minus 36. For the second row, I will have 2y plus 5z equals to 8. And for the first one, I have 3 plus 3x plus y minus 2z equals to minus 2. So here, in my first equation here, I can easily get my z, because it is linear, it looks linear. So by dividing both sides by minus 18, I have z to be equals to 36 over 18, and that's equals to, what's that, 2. Yeah, 2. So I know my z to be 2. I can find my y in my equation 2 here. So my y will just be 2y plus 5 times 2 equals to 8. And that will be equals to 2y equals to 8 minus 10. So I have my 2y equals to minus 2, y equals to minus 1. Take note, y equals to minus 1 and z equals to 2. So me knowing y and z, I can know my x using the last equation here. So I have 3x plus, what's y? Okay, minus 1. Minus 1 minus 2, what's my z? 2 equals to minus 2. Okay, let's get that. 3x minus 1 minus 4 minus 5 equals to minus 2. 3x equals to minus 2 plus 5, which is equals to 3. So x equals to, by dividing both sides by 3, I have my x to be 1. So my x, y, and z, x, y, z is simply 1 minus 1, 2. So that's it. If you can check the results of this method with the one we previously did, you will see that it is the same. Okay, welcome once again for the second part of our class, system of linear equation. So in this video, we are trying to use the row reduced echelon form to solve the same example we've been treating. So let's start. So for me to use row reduced echelon form for this, just like the one we previously did. So I have to put it in this form: ax equals to b, which is the same thing as 3 1 minus 2. Don't forget, I told you we slot the coefficient as an argument in a matrix, and also 2 4 1. So drew a line like this: minus 2 2 0. Okay, so your goal in this method is just what? To try to reduce again, but make sure that all your pivots, they are 1 and 1, and after then every element below and above your pivot must be 0. Element here must be 0 0 0, and also the ones are above. Every element above and below your pivot must be 0. Okay, yeah, let's try to reduce this like what we did before. So for me to reduce this, I can just say 3 times row 2 minus row 1. 3 times row 2 minus row 1, and that will give me, let me rewrite my row 1, 3 1 minus 2 minus 2, and then 3 times 1 3, 3 minus 3 0, 3 times 1 3, 3 minus 1 2, 3 times 1 3, 3 minus 2 5, 3 times 2 6, 6 minus 2 8. Take note. Okay, for the third row, for me to reduce these two, I can just say 3 row 3 minus 2 row 1. Don't forget, just like I did before. So 3 times 2 6, 6 minus 2 times 3 6, 6 minus 6 0. Let me block you. Okay, again, 3 times 2, 3 times 4 12, 12 minus 2 10, 10, 3 times 1 3, 3 plus 4 7, and also 3 times 0 0, 0 plus 4 4. Okay, we are going there. So the next thing is just to try to reduce my 10 here, so that I can have every element below my pivot to be 0. And for me to reduce this 10, the next thing is just to draw my matrix. I have 3 1 minus 2 minus 2. Am I right? Okay, 0 2 5 8. And also, okay, for me to reduce my 10 here, I can just simply say my third row, which is now what? Row 3 minus 5 row 2. So the only thing that changes is that in this case, I subtract row 2 from row 3, not row 1. The reason I cannot use row 1 here is because of the principles of reducing. Because if I should use my row 1, my 0 here, my 3 here will make me to terminate this 0 here, which is not what I'm following. So I have to make use of my row 2 because I already have 0 as the initial element here. Okay, let's go. So 0, which is row 3, minus 5 times 0 0, and then 10 minus 2 times 5 10 0, 7 minus 25 18, minus 18 rather, and then 4 minus 5 times 8 40, that's minus 36. Okay, yeah, let's go. So I know my pivot now, my diagonal element 3 2 and minus 18. So my next goal is to make sure that every element above my 2 and my minus 18 are zeros. And how do I achieve that? So I can just say, for me to reduce my 1 here, I can say, for me to reduce my 1 here, what can I do? I can just say 2 row 1 minus row 2 minus row 2, and that will give me 2 row 1 minus row 2. 2 times 3 6, 6 minus 0 6, 2 times 1 2, 2 minus 2 0. You see, 2 times minus 2 minus 4, minus 4 minus 5 minus 9, minus 9, take note. And then 2 times minus 2 minus 4 minus 8 minus 12. You see that I did it. Okay, let me rewrite my second row. 0, 2, 5, 8, 0, 0, minus 18, minus 36. Okay, what's the next thing? The next thing is to reduce my what? Minus 9 and 5. Let me start with 5. Okay, oh yeah, don't forget I said I want to reduce my minus 9 and 5, but let me start with 5. Don't forget my 5 is my second row. So how do I reduce that? I can just say, for me to reduce this 5, let's think, how do I go about that? I can just say minus 18 row 2 plus 5 row 3. Let's see if this will work. Minus 18 row abi before I do that, I can just say this my row 3. I can rewrite it as, let me break things down. Let me rewrite my matrix. So this here, I can see that all my entries in row 1, they are multiples of 3. So I can just break that to 3. I want to divide them by 3. So 6 divided by 3, that's 2. 0. Minus 9 divided by 3, minus 3, minus 4. Are you there? Okay. My second row, 0, 2, 5, 8. And my third row, I can just divide that by minus 18, since I have them as multiples of minus 18. So 0, 0, 1, and then 2. Okay, I can see that I have them in a simpler form. So for me to reduce my 5, I just have to do row 2 minus 5 row 3. Okay, yeah, let's implement that. Let me write my row 1. 2, 0, minus 3, minus 4, and also 0, 2, 5, 8. Okay. Oh, sorry, I want to reduce row 2. Okay. So 0 minus 0, 0. This one, 2, which is row 2. 2 minus 5 times 0, 2. And then for this one, 5 minus 5, 0. Okay, take note. And also the last one, 8 minus 5 times 2, 10. 8 minus 10, minus 2. Take note. Okay, let me write my third row. 0, 0, 1, 2. Okay, what next for me? Don't forget your line. So the last thing for me here to reduce is just my what? This my minus 3. And how do I go about that? I can just say, for me to reduce my minus 3, I can just say row 1, minus 3. I want to reduce. Take note. Okay, my row 1, I can just say row 1 plus 3 row 3. So let me try that. Row 1, so 2 plus 3 times 0, 2, 0. So minus 3 plus 3, 0. Minus 4 plus 6, that's 2. Yeah, 2. Okay, what did I have next? 0, 2, 0, minus 2, and also 0, 0, 1, 2. I can see now that my pivots here are what? 2, 2, and 1. And don't forget, I told you that before you can call them pivots, everything must be 1. And how can I turn this my 2 to be 1? I can just say 1 over 2 row 1, and also 1 over 2 row 2. You can see that my pivot here is already 1, so nothing to do to that. So I just have it to be 2 divided by 2, 1, 0, 0, and then 2 divided by 2, 1. For this case too, 0, 1, 0, minus 1. So since I'm dividing it by 2, and for the last one, 0, 0, 1, 2. So I think that's all. You can see that I already have my pivot, and I have every element above and below them, every element above and below them to be 0. So actually, in most cases, it's not always a unit matrix like this. The reason why I have a unit matrix here is because my system of linear equation is a well-determined one. In a case of over-determined and under-determined, it's not always a unit matrix, but the main thing is just that under every pivot and above them, your elements are 0. So now I have my answer on the other side, which are what? 1, -1, and 2. So those values, they stand for my x, y, and z, which are the values of my variables in the system of the linear equation. So I have my x, y, and z to be equals to 1, -1, and 2. So that's that for that method, for the method of row reduced echelon form. So you can still see how we end up with the same answer. So thank you.